Okay, today we are going to discuss a couple different things. First, we're going to do using a reciprocal to eliminate a fraction in an equation. So, first of all, your vocabulary consists of a reciprocal. You need to know what that is. And basically, that's the inverse of a fraction. So if you take a fraction and flip it over, the flipped over part is the reciprocal. So here is your fraction. Here's an example. The reciprocal means we flip it over. So 8 goes on top and 7 goes on the bottom. And this is the reciprocal of the original. To get rid of a fraction that's next to a variable, you multiply both sides of the equation by the reciprocal. So let me do one for you so you can see exactly what I'm talking about, and then we'll do some more in class. Here you have the variable right here, which is what we do not know. And attached to it by multiplication, and I know it's multiplication because they're touching each other like that, is a fraction, and it's 3/4. Now, in order to find out what C is, you already know that I need to get it by itself, which means we need to get rid of this fraction right here next to it. To get rid of it, all we do is multiply by the reciprocal. And again, the reciprocal just means that we flip this upside down. So I'm going to multiply by 4/3. And what I do to one side, I'm going to do to the other side. That means I'm going to multiply this by 4/3. These are going to cancel out, leaving me just with the variable on the side. I'm going to have 18 times 4/3. This does not have a denominator, so we're going to give it a denominator of 1, because any whole number that you have here that does not have anything underneath always has a denominator of 1. And then we know when we multiply fractions, we multiply straight across. So we're going to multiply 18 times 4 and 1 times 3. 1 times 3 is 3. And then we'll do 18 times 4 over here to the side because I don't have my calculator out. 4 times 8 is 32. Carry the 3. And 4 times 1 is 4 plus 3 is 7. So I have 72 thirds. Now, I want to see if that's reducible. It's okay to have your numerator right here as a bigger number. We did do that in 8th grade. But before I leave it this way, I need to make sure that this is not divisible by this. So let's try that out just to check it. Is 72 divisible by 3? Well, 3 goes into 7 twice. 2 times 3 is 6. I'm going to subtract that, and I have 1 left over. I bring down my 2. 3 goes into 12 4 times. 4 times 3 is 12, which gives me 0, which means that this is divisible. So we can break that down to 24 that I got right here. So now we know that C equals 24, and that's how we get rid of that fraction next to the variable. We'll do more of these in class, and we'll practice a lot. So don't be worried if you don't get it right now. The next thing we're going to do is combining like terms. This should not be new for you. This is just a review. And a like term is any term in an expression or an equation that has the same variable raised to the same power. For example, you have 8x plus 3x. Both of these have an x as the variable, and they both have an exponent of 1, or for you right now, they don't have an exponent, but we know that 1s are invisible. You'll learn that later in the year. So because they have the same exponent and they're the same variable, you can combine those together. You just add the numbers together. 8 plus 3 is 11, and carry the x. Here, this one has an exponent of 2, and this one doesn't. So you cannot combine these two variables, even though they're both x. They need to have the same exponents as well. So let's do an example real quick. Oh, never mind, we have steps first. The easiest way we can do combining like terms is to box and circle. I like to use circles and boxes, triangles. Usually we don't have more than 3 things in any equation in 8th grade. So these are my 3 favorites right here. Every now and then I'll use a star or maybe a diamond in case I get bored, you know, stuff like that. So what we're going to do is we're going to box and circle our stuff, and then we're going to combine the shapes together. Our goal is always going to be to only have one of each shape, or one of each variable. You should probably write that down. Okay, here's an example. So again, we're going to use boxes and circles and triangles because those are my faves. So right here, I've got a variable of x and an exponent of 2. So those are the 2 things I'm always looking for. I'm going to put a box around that one just because it's the first one and I like boxes. Notice how I added the sign to it that's attached to it. Now I'm going to move on to the next one. This one has an exponent of x, just like this. However, it has a variable of x, just like this one. It does not have that exponent of 2, though. So this is different than that because they don't have the same exponent. So I'm going to go to my next one, which is a circle, and I'm going to circle this. And notice how I circled the sign that's attached to it as well. The next thing I'm looking at right here is 8. And notice how they're all separated by operations. The 8 does not have a variable here, which means, again, I have another different one. So I'm going to put another shape here. So now I have 3 different things here. And I'm moving on to the next. This has a variable of x, just like my box and my circle, so I know it's going to be one of these 2. It does not have any exponent here, which means that it cannot be a box. But it can be a circle because this also does not have an exponent. So I'm going to circle this, including the sign in the beginning that's attached to it. And last, I have the -10, and there is no variable next to it. So I'm looking for the one that has no variable, and that is my triangle. So I'm going to put a triangle with that. And now I'm going to combine them. I do not have any other boxes, so I'm just going to bring that box down right there. I have 2 circles. I need to combine those together. I've got a 6x that's a positive, and I have a -x, and we know if we don't see any number next to that, we know that it's a 1. So I have a -1 and a +6, which gives me a +5, and the variable comes with it. And next I've got my triangles. I've got 2 of those. I need to combine those together. One of them is a -10, and one of them is a +8. And if I combine those together, I'm going to get a -2. So I'm going to add that to my little train going on down here. And now my check is to make sure that all of them are different. Because remember, my goal is to have one of each. So this was my box. I have 1 box. That's good. 1 exponent of 2. This one is from my circle. I have 1 circle that has a variable but no exponent. And this is from my triangle, which was a number that had no variable. 1 of each. So I did it right because I only have 1 of each. And that is all you need to do for combining like terms. And that is the end of the lesson for today. We will do lots of these in class, so don't worry if you're still a little bit confused. It will be okay.